Good afternoon, everyone. It is a very great pleasure to have today with us Jonathan from AMRC Sheffield to present to us the potentials of digital twin technology. So his focus talk today is going to be about untangling the requirements of a digital twin. This talk, as you know, is one of the monthly featured talk event that we do regularly as part of our EPSRC digitalized surface manufacturing networks effort. And this network is now continuing to make its impact to the network team, including the support from the PI, Professor Alan Matthews from University of Manchester, Professor Ashutosh Tiwari from University of Sheffield, Professor Adrian Murphy from Queen's University Belfast, and myself as being part of this team initiating these events. So to introduce today's speaker, Jonathan is a technical lead for digital twins and advanced visualization at the AMRC. He has been working on a wide range of specific client work, large funded projects focusing on visualization and connectivity of the integrated manufacturing data. He is also responsible for delivering research across a wide range of manufacturing sectors, both including additive and subtractive means to deliver end-to-end solutions and to solve specific industrial challenges ranging from understanding point solutions to the wider business adoption, transformation issues, and business function with new methodologies. So it's going to be a nice one to add to the current desire of digitalization of manufacturing processes and digital twin sitting at the interface of it pretty much. So I look forward to this talk personally, and we will have a Q&A session at the end of the talk. So with that brief introduction, Jonathan, I welcome you to the DSM family and hand over this podium to you to take over the platform and give us a talk.
Yeah, thank you much, and good afternoon, everyone. If you are joining live as well, please feel to drop questions in the chat as we go through. And if I can pick them up as I go through, happy to do so. But as you mentioned, we'll leave time for questions at the end. So going through the requirements of digital twin then. Digital twin is one of the topic areas which often gets mentioned, often misused, as you may understand if you're working in this space. And really, this presentation is going to be around breaking down the requirements of what it means to have a digital twin, what the fundamental aspects are, and also a use case at the end, and going through kind of the advantages of going forward with digital twin technology. So just as a piece of context then, it's an old concept that is being reinvigorated with a lot of new technology, when the new part being just the digital aspect. So what we have done in the past is kind of ad hoc information being shared. Obviously the cloud technology in the years gone by wasn't there. So kind of a real case in point example was the sort of Southwick House war room for the Allied invasion of the D-Day landings. There was radio data coming back of locations of kind of how the forces were doing with the landing, and that information, the live connection needed for a digital twin, was just being radioed back. But as that's progressed and technology has come down, obviously it was expensive, as sort of NASA were sort of some of the first major players in this space. The millions of pounds of investment that they had meant that they could have digital twins. But now, as consumers with sort of IoT technology, cloud technology, sensors becoming cheaper and cheaper, it's around us all the time now. And that's really where digital twins are now really kicking off, is with all of these advancements from consumers through to home automation technology, through to within the manufacturing space and other sectors. There's a lot of advantages and a lot of ways that you can get into this space with actually having this, sort of a lot of this now in place for us. And Gartner, who you expect are doing a lot of research in this space, is sort of estimating, I'd say quite conservatively from my experience, that there will be sort of at least 10% improvements in effectiveness. Now, I appreciate that's quite a broad term in terms of what do you mean by effectiveness. That's across the board. If you're looking at sort of asset utilization, if you're looking at costs, everything, just blanket of 10% is some real significant advantages for what we're looking for within digital twin deployments. So to kick things started then, the AMRC have been working in this space for quite a number of years now, and this is kind of all feeding from a report that we published, which I'll link through to at the end. And this is what we're now defining going forward as our definition of digital twin. Is it's a live digital coupling of the state of a physical asset or process to a virtual representation with a functional output. Now, there's 6 key parts in there: live, digital coupling, state, physical asset or process, virtual representation, and functional output. And these are what we're saying are the 6 fundamental requirements of having a digital twin. And it's not that you can have 1 or 2 or 5, is that you must have all 6 captured to have a digital twin. Now, that sounds daunting, but actually, as I was mentioning before, we have these as consumers all of the time now. And this is what I'm meaning is Google Maps is actually one of the world's most sophisticated digital twins. It's live because the weather's happening around us all the time. It's digitally coupled, i.e. when it's changing outside, it's lovely and rainy today in Sheffield. It's reflected on applications, and we can see that within the digital architecture of the applications. We can model the state information through temperature, through humidity, through what the actual understanding is of the weather. And as I mentioned, it's physically happening somewhere in the world, i.e. it's outside in the real world now, and we can virtually represent that with information and databases, and it's how we want to capture that information and understand it. And the functional output is actually the last bit that you see. It's the piece on the right, the mobile phone application or the website or where you go to check the weather. And now this is the minimum requirement of a digital twin. It's a supervisory system, if you like, of having an understanding of what is happening out there in the real world on some form of virtual representation. But what the real advantage of digital twins is going forward, it's not just an amalgamation of data, it's having that information available to run prediction models, to understand how we can run it better in the future, how we can kind of gather historical data as it's happening live and then utilize that for AI or kind of other technologies that allow us to do things better. And it's that step change of improvement, which is what digital twins are really here to enable. So going into the details sort of a little bit now then. So live is when state information is available in a time frame that is close enough to the underlying event. Now, live is one of the most contentious parts of digital twin, of around what do you mean by close enough? What do you mean by a time frame? And that's really the point of it. A lot of people, when they first come across digital twins, think real time. They think, oh, I want the information as soon as possible. I want to know exactly when it happens that something's changed so I can run simulations all the time. Whereas actually you're saying, if in other examples, you don't need it, what if every 5 minutes is good enough? Well, that's exactly that. If it's close enough to the underlying event that you're happy with what the information it's producing, then that's good enough. That's good. And actually, some of the work that we did back in 2018 around this was actually saying 85% of engineers would actually see this just as monitoring applications. And a lot of monitoring applications are just a report of the latest information that you know. It isn't straight away that you understand everything. It's as and when that information is available, as long as it's good enough for a use case, is acceptable. So digital coupling is then the counterpart to live, really. It's that transmission mechanism. So it's over the Wi-Fi, it's over sort of MQTT brokers. It's how do you want to transmit that information from what's happening in the real world through to what's happening in the digital space. And state, there's actually 2 parts of state, which I'll run into a little bit, but it's how you want to describe the particular condition or the way that that physical asset or process is being modeled and how you want to gather that information and store it somewhere else. So it's the state information that goes over the digital coupling. So the physical asset or process then is, as we've seen, the weather outside, but it's really anything that you want to understand. It's that entity which has that economic, social, or commercial value of something that you have. And again, this is one of the things that so a lot of people come across the term and they say, oh, look, digital twin is a simulation. Well, no, you absolutely must have something physical in the real world that you're synchronized to. And that's really a core requirement to have something physical that you're then mapping to the virtual space. And by virtual, I mean some way of describing or having a logical model to a physical asset. If you're dealing with robotics, that could be something what's commonly called to as the URDF or Universal Robot Description Format. If you're working in other aspects of engineering, it could be the CAD model. it's however you want to describe it, but it's not a one size fits all. It's very much how do you want to describe what's happening out there in the real world, and then the rest of it falls into place to enable that live information to come through together. And finally, then it's the functional output. So information being transmitted to a system or human observer that is actionable to deliver value. And this is included because if you just have the first 5 parts or first 5 requirements of what I've just explained and gone through, it's great. You could have a virtual representation of something happening and nobody would ever look at it, or nobody would ever have a way of understanding what the information is actually meaning, or it's not accessible to anybody. So that's really what this last part is around, is it accessible to engineers, people who need to consume that data, or is it that it's accessible by another digital twin, so then somebody else can utilize that information? So back to the weather example, weather stations across the country, the Met Office wants to gather all of that information and start an analysis and derive extra information. They have digital twins of each of their assets and weather stations, and then they bring it all together of their each individual functional outputs to then have better information within inside a different system. And for those of you who want it sort of laid out, this is kind of where we're getting to now. It's that we have a physical asset or process that we can describe with state information that is live and it's digitally coupled across to a virtual representation with the counter state information. And then we have that functional output. The key also consideration here is that it's single direction of travel. Is for the fundamental requirement of a digital twin is that we have a one direction of from the physical asset, we can go to the virtual world. However, a lot of deployments as a core requirement is that you have bi-directional communication, or the ability to have bi-directional communication. What we're saying here is it's not essential, is you can just have a one-way mapping. So at the end of all this then is kind of the first part of this talk is getting to is that we have 6 requirements for digital twin. And this is work that AMRC has been doing, as I mentioned, for quite a number of years to get to this point. And it's kind of the work that, yes, we've been doing in the manufacturing space because of the nature of our research organization, but it's also now been adopted more widely within the other sectors that we're working with, as well as now as a HVMC adopted definition of this is what it means to have a digital twin. And it's not just what we're saying. There's work in progress standards, so the BSI one mentioned here, and also a position paper coming over from America. So again, worldwide, not even just UK, around it must be a connected physical asset. Even so far on the bottom right is from the AIA and the AIA of if you don't have a physical asset, then you don't have a digital twin. So simulations just off the cards. If you have a simulation, that's great. It'll deliver you a lot of value if done correctly, but it's not a digital twin. And then at the bottom left as well, just at the bottom there, it's the appropriate rate of synchronization. So again, coming back to what we've previously said, it's around if you have information in a close enough time frame, then it's that appropriate rate of synchronization of having data available for you to do whatever you need to do with that information being available. So live then, just drilling into some examples to kind of just reinforce what we've been discussing then. So time frame is the key one there. So it could mean anything really that you want. A machining process, which is the typical example, is 10 hertz or kind of as fast as you can to deliver vibration analysis or kind of understanding in real time what is happening. But for glaciers that move very slowly, once a week could be good enough. So any point during that week or any point you could query that information source and go, what's your position or what's the current state of the glacier? Sampling it once a week is good enough for that use case. But the flip side of both of these is that these are what's known as polling, of every so often at a set interval, you go and query that information. Whereas actually in a lot of examples now happening within manufacturing, it's, hey, just let me know when it changes. So a door, when it opens, notify me. When it closes, notify me. So what this means is this door could stay open for half an hour and you would not hear anything on the network. But as soon as it changes, you've got that information straight away. And it's still live and connected, and having the right technologies deployed and implementations for a lot of this is that actually you have that reliance on the network to say, yep, I know and I can guarantee the state of this information that whenever I query it, I know it's up to date, even if I haven't heard anything for quite a long time. So that's live. So I've partly answered this already, but it's always good to just run over it of if you have a physical asset here from a CMM machine and you've done a metrology inspection of and compared this to MBD information, then you have had a physical comparison of something that exists through to the virtual counterpart, and you've compared it to generate this report. But as you've gathered, no, it's not a digital twin because it's a one-off sample point. You've got no intention of updating it, and you've got no way of having a digital and live connection through to this being constantly updated. If you did, then you'd at least meet the live requirement. But within this example, you don't. Digital coupling then. So it's the understanding that mechanism between data source and data consumption. So traditionally within manufacturing, there is a lot of OPC UA protocols. There's a large shift at the moment moving towards more MQTT, which a lot of OEMs are now starting to adopt, as well as in smart home devices. Yes, it's over the Wi-Fi and it is using MQTT, but it is consumer driven now. And a lot of that is sort of piggybacking off your home Wi-Fi setups. So state is what I mentioned before, is around two parts of this really. So the first part is, well, what are you actually describing? So a robotic arm could be joint positions, it could be what end effector have you got, when we last used, what's your current draw, and a lot of this information is how you want to describe it. But the same exists for processes and supply chains. Processes could be what machines are currently running, kind of what sort of the bandwidth, who's available on the shop floor today. Whereas supply chains is what's the location of everything, what's our current asset utilization across the business. So it's however you want to describe it really, and it's that mapping of across that specification. But the second part is then sort of more intrinsic around, well, how do you want to describe it? You know what you want to describe, but how do you want to do it? And these are just three examples. Tag tables, again, for manufacturing is from PLCs. You could just use CSV data as long as you could define your columns and what data you're expecting. But more common and sort of an alternative to XML is what's known as JSON. And this is a very open format around describing information. And if you have these common JSON models, then you could describe anything you want from the previous sort of state information to then transmit over the digital carrying medium. So here we have another little question around state. Is a load of numbers state information? Some may argue yes, some may argue no. My answer to that is, what does it mean? Until you have the context of what all of these numbers mean, how do you know what to map it to from the physical world to the virtual world? So if you then apply units, apply how often was these samples taken, where's the location, and all of this information, then actually, yes, if you have that context, then you can actually meet the state requirement. And that's the key thing there. If you need the context of units and everything else, and what's traditionally known as meta information, to actually have a good, clear understanding of your state information. Physical asset or process then is the entity that has sort of that value to everybody. And these are commonplace. You'll come across lots of examples within this, but just to name three is the traditional wind turbine that often gets mentioned for digital twins. But more of the other concepts that we have in day-to-day life is a restaurant. Having a live understanding of where is everyone sitting in a restaurant is a digital twin, and then can be utilized for understanding what's our current bandwidth, how many people are waiting for meals currently, and that. So there is things that are happening all the time that you could model with and have a deployed digital twin. As well as brewing process. You have chemicals and sort of brewing process that you want to understand and have connected to make the best value, make the best brew possible. You may want a digital twin of that process, but it's certainly a physical asset or process that is existing now that you want to have better visibility of. And then virtual representation is also, again, however you want to describe it. The bottom right is a value stream map, which is one of the more basic models possible. However, it's a really good way of just capturing what's happening when, where are we on this current process, what's the flow, And from that then is you can have state information feeding into this to drive the digital twin if you want to. Two other examples around electrical schematics through to more traditional simulations of CFD, FEA, kind of what you want to model to understand what's happening. So that, again, when you apply the state information, you can put that into context and understand a little bit more around what's happening. And finally, then, the functional output is again the output of what you want to see. This could be a dashboard, as simple as that. It could be a REST access for another database or another digital twin to access that information, so it can always be involved with what it's doing. Or you could go to the extreme of an immersive environment. So if you're looking around a large construction site and you want to see what's happening in it, you could link that through to the live data so you know exactly what's going on without actually being there. Or it could be prediction on top of that, of saying, I want a predictive graph. I want to understand, yes, everything that's happening, which could be a dashboard, but also let's start building on top of that. Let's start understanding what we think could happen in sort of the future. And the main thing here is that all of these three and all of the other outputs of that are available are delivering value. It's that way of understanding the system to see what's happening. So again, just to recap, there's 6 requirements and there's a lot more detail in the report if you are looking at getting into this space. But it's a case of you have all 6 and you met all the 6, then you do have a digital twin. So there's 2 main ways from our sort of understanding and working in the space of categorizing a digital twin. The first one is kind of how you want to break it down, which you've seen a little bit of already. Is it an asset? Is it a process? Or is it across an enterprise? So asset is the one-to-one kind of, I am the singular device, it's unique, I want to understand exactly what that asset is. It could be location, it could be position, it could be any one of the things. And normally a lot of these, what we're seeing at the moment, is having those sort of dashboards available of, I'm a user who needs to see exactly what that device is doing, let me know about it. Whereas process is a lot more around, yes, it might utilize digital twins of assets and bring in certain information, but it's a lot more around sort of the value stream mapping or understanding what's happening through a process to focus on the behavior of that process. Again, to make step change is to make the improvements of that information being available. Whereas enterprise is a lot more around fleet management, is those larger, big strategic decisions need to be made as an enterprise to understand who should be working with on your supply chain. What is the impact of COVID on sort of supply chains and how it modeled? If we had live and connected information of that, businesses would have been able to make better decisions around who they should have been supplying with. And certainly, I think over the last year, we've had a lot of inquiries around this of how can we do this better for these bigger, wider strategic pieces. And the second one is around the nature of a digital twin. So we've broken these down into supervisory, interactive, and predictive. These are stemming from the work that we actually did back in 2018 as well, and refreshed slightly. But these still hold up for what we're working with. Is sometimes the easiest way of doing it is that dashboard, and you just want to supervise it. But it's never to forget that in the future, you may want to interact with it and have that bi-directional communication now to say, I want to control the system to now do this instead, or I want to run this machine faster. Can you enable that, please, from the system without actually physically going to the device and changing it on the device? And then the predictive builds on top of that is that you want to have more complex information or better understanding of what you're doing. So remaining live, how much power is it using? When should I switch it off? What's the best way of running this machine to make, again, those step changes? With regards to the 3 is looking at the functional output. So by having the core of supervisory, because you always have state information flowing, is that you always have the functional output available. So regardless of what you're up to, you have that functional output and you can still map yourself across these 3. So moving on to some case studies. There's a few that come up quite a lot. Wind turbines, jet engines. There's a few facts and figures out there. One of the most sort of common ones that comes up is reactive maintenance of if I know what the system's doing and I no longer have to go, oh, it's just broken, I need to go fix it. If you're aware of it and you can schedule it in, And sort of that reactive maintenance is sort of quoted around 40%, which is quite a big saving for a lot of manufacturing. And one key part that is coming up now is the next generation design. Now, a lot of digital twins are spoken around. We're designing a new product. We have a digital twin. It's like, well, you don't because it's a simulation. But they're saying, well, yes, but we're using last generation to influence next generation. It's like, well, yes, you're using the digital twin of last generation, and it's happening to influence your next generation design, but you don't have a digital twin of your next generation design yet. By that, I mean, if you're understanding how a mobile phone is used, so the stresses and strains it gets put on in our pockets, how it looks at sort of the stress analysis of what factor of safety was that designed with. If a component never breaks, it was either perfectly designed, or actually maybe the factor of safety was too high. So you could reduce the factor of safety, better understand what that component's been through, and then actually save weight. And of course, everybody knows the sort of saving of weight influences material design. It could reduce a lot of quite a things and actually influence a lot of the design. So digital twins can enable next generation design, but don't necessarily are of the next generation design. In hospitals, there's some big work being done around IoT connectivity of hospitals, which are a digital twin. Not necessarily enabled that. And that's kind of the key point there of a lot of the work going off in other sectors might not call it a digital twin, but it's just within sort of what we are coming across is a digital twin. So real-time insights of doctor locations, nurses, patient health, that sort of whole flow around a hospital environment is a big drive towards operational costs. And one of the systems that has come out by ThoughtWire has actually decreased code blue events by 61%, which is a phenomenal amount for the sort of saving lives and everything else that goes with it. So yes, it may be a quite primitive of what I last saw of it, of supervising systems, understanding what was happening, but the reaction of kind of almost maintenance and all of these other things that come with it across the sectors is a real big driver for just having better visibility of what's going on with the systems. So more general then, what are the benefits? So supervised digital twins of kind of this primitive kind of dashboarding. I just want to see what's happening better without having to go up to the machine or go up to the asset or kind of go and ask somebody what this information means. Is we've seen a German automotive quoted that it costs them 40,000 euros every minute that it's down. And actually by saving that is a 50% reduction in unplanned downtime from just having information right across. So it's a real key driver, as I mentioned, for downtime and knowing when it's going to happen and scheduling all that in. We've also heard of a forging line that's proactively fixing one of its major clutches, and that's saved them $200,000 a year now because it's been running ever since, because they understand when the vibration gets too much, and they've built all of these machine learning algorithms around it just to understand what that means. So on average, digital twins are sort of having that 40% reduction in maintenance costs. Then some of the smaller values, but not necessarily insignificant ones, is capital costs of buying new equipment and reduction of energy costs. Now, while these again are smaller, it's not necessarily say where they're aimed at. So SMEs, if they could save 5 to 7% of their energy costs, their whole business could be a lot more profitable. And then it's the same for capital equipment costs. When they're saying, I need a new lathe, well, do you actually need a new lathe? If you have better visibility of your utilization, you just need to redistribute the way that you're manufacturing things to say, prioritize this work and then do this as secondary, and you've actually got enough capacity within your equipment. So one of the case studies then, BAM Nuttall are a construction company working in the UK and working with IoTics. And one of their key drives is because of the margins of the construction sector being so small is, they've got some R&D investment and they want to improve, but they have to always improve on today, but they will also want to scale it into the future as well. So the construction sector is a complex problem. There's plans, there's conceptual information, there's the UK weather to deal with. There's a lot of operational tools as well to go with it all. And when you start to bring all this data together, you end up with something looking like this, of the weather and all of the parts needing to come together. And that's complex, and it's needing a lot of integrations to understand and to develop this together. So what IATIX worked with them around was setting up twins of all of these different parts that can affect construction sites to supervise information. And one of the key takeaways from that work is that all of these suppliers offer them an app to monitor their bit of kit. But that also means on a tablet, you need 20 different apps. So that's not much use to them. What they want is a single platform which can have all of these integrations and have that dashboarded how they want to see what's happening. And then on top of that, they can start building the prediction model and start understanding how things are moving forward. And actually, one of the key drives that they've got from this is when they've got 4 or 5 construction sites close together and they've got a dumper truck on each of them and they're only being used 10, 20%, they can actually save now and just have certain assets being used across the different sites by just saying, well, we can take that off lease because that can actually cover that work. And they're saving money now by just having that information available, even just as a starting point for what they want to do in the future. And Frazer-Nash, so the other extreme really of, they've been investigating maintenance procedures of a large fleet of turbines, looking at sort of MRO of high value parts and inventory upkeep. Now, typically blades are just done on safe operating hours. Once it's been in there for X amount of hours, they say, right, that's it, that's now scrap. We just move on to save this sudden failure because of just the sheer cost of what that would mean to the engine. Now, the challenge with that is they have very limited information of the actual blade where they're looking at. So the part shown there is actually just in the just after the combustion section in the turbine, and that's where sort of the really hot gases are going towards the exhaust. The only things that they really have is inlet temperature, outlet temperature, and rotational of the engine, or rotational speed of the engine. So they've built a rather complex mathematical model to distinguish this. And it's that simulation model to start with, just to understand, does this work? And what they've now done is move that forward then and created it, tested it, validated it of all the mathematical models to quantify a blade's remaining life. And then they've now enabled this with sort of being able to run it in real time. Obviously, digital twin being the live component, is that by reducing the order of the model for live predictions, it means whenever they get sent blade information running live off the systems, they can understand what's that blade's life like. When do we need to actually replace the blades? So yes, they've had to approximate, and yes, they've had to try and get down to what they're doing accurately. But the key takeaway here is that the project reduced failure risk, overhaul downtime, and cost for a lot of these blades. And working with the client, they've actually got over this sort of large research program they've done with them, and now looking at return on investment within 2 years. Yes, this might be because of the high value nature of the component, but taking that to the extreme and what they're looking forward to is 5 times return on investment within 5 years. So actually, once you start to chip away at digital twins and having this live connected data, then actually the return on investment can be quite significant looking forward. So it's not just when do I get return on investment, it's what does that mean unlocking new value into the future as well. It's a bit more of a worked example then, just jumping into some of the details. We have at the AMRC a reconfigurable assembly cell. The robot here is driving a pogo matrix in the center. So the little post in the middle there. The rotary table on the end holds the leading edge of the aircraft. So they're like the rib sections on the end. And as I mentioned, there's a robot moving it all around. What we wanted to do with this one is we'd already built the physical on a different program of work. We wanted to enable it with a digital twin to compare what's happening physically to what's happening virtually across shop floor network and looking at other things like the enterprise architecture. But the reason we want to do it is to prove that we can ask what if scenarios of processes happening within a digital twin. And the value behind all of this from sort of the clients we're working with is they want simulation tools to be embedded in other people's toolkits. So not simulation experts, they want it to be in the shop floor managers of saying, they want to know, what if I run it this way? What if I run it that way? So they're the key decision maker. They just need the backing of the simulation to prove that they're doing what they need to do and the best way of running something. So we started with the physical at the top left. We then started describing the state information, so the robot joint angles, the end effector status. And then for the sake of argument, we'll describe this as JSON, which is what we did within this program of work, as I mentioned earlier. The next part, as you've seen from the requirements, is it's live and it's connected, and we're doing that at certain speeds. So the robot joints, we'll just say will follow at 10 hertz, whereas others, fixture change, process change, might just be whenever it changes, because that's going to be less frequent. And this live and connected is a program of work we've done internally with Factory Plus, and that's the adoption of the Eclipse Sparkplug Foundation and specification, which I've got another slide on, so I'll go into a little bit more detail around that. And then we have this. Is that a question? Nope, I'll continue on.
Yes, I have a question.
One, Khalid.
Do you know Candice?
Jonathan, please go on. It was probably some noise.
Yeah, it's fine. I'm just ejected him from the meeting. So connects it now to the virtual representation. So here we have a Unity model that we've mapped all of the information coming through from Sparkplug. So what that gives us then is the functional output of an immersive environment. So this could be desktop screen, this could be VR, and what we're looking there for is the understanding of what's actually happening in the cell. So what we're looking here at is, yes, we have all the state information that could be dashboarded, but actually by mapping it to the understanding of the CAD model, by how it's moving around, when you have such complex information, such as robot joint angles, understanding and looking at it makes a lot more intuitive sense at a glance than it does just to have 100 different states listed. And for those observant of you early on in the presentation, is you'll see how this maps to the diagram I showed earlier of the minimum requirement to have a digital twin. So we have the physical, it's coming through to the virtual, through all we've discussed over this last 40 minutes to have this functional output that's available. And that gives us that supervisory digital twin. The Factory Plus that I mentioned then is the adoption of the Sparkplug specification, and this is available at the link on the slide, which will be distributed after this presentation.
Yes, I fucked him last night.
And what we are looking at doing
Don't fucking
is
remind me. Yes, I fucked him last. I sucked this big. It was so big I can't. Oh my god.
Sorry,
bro.
I'm sorry, I don't know what's going on.
it's somebody's got access to the details.
Please go.
So we are looking at the definition of and the adoption of the Sparkplug specification, which is available at this web URL here. So yeah, if you want more information around this, by all means reach out afterwards. But the key thing here is it's the adoption of the MQTT specification that I mentioned earlier. And it's all about the open standards now driving a lot of the connectivity. It's what we're now supporting internally. So example architecture of why a lot of solutions that are working in the digital twin space is actually the sort of point solutions is a lot of what it is. So you have PLCs talking to ERP systems and MES, but a lot of the information, it's every time you come to do a new link, you're doing it as a bespoke solution again. So the whole point around Factory Plus is the adoption of Sparkplug to enable a unified namespace for everything to communicate. So the moment that you need a new digital twin or the moment you need a new system to be put in place is you can access the unified namespace for the information that you need. There are open standards in place around how you access that information. Then you can just retrieve that information as you need it within this sort of understanding of what this data is coming through as. So here's just a slight rework of the diagram and just mapping this now across to the other diagram with sort of supervisor, predictive, interactive. What we have there is just the supervisory information. But what we also did within this program of work was look at a discrete event simulation. So we took the state information from this virtual representation, and also modeled the process information. So we knew rough approximate times. That then we could feed back into the digital twin, which meant actually now we have this predictive element looking at how it feeds back into the virtual representation, which we can then use to drive back into the functional output. So after that, then we can start looking at predictive elements of when's the completion time, what the knock-on effects of that over the whole supply chain, and then also the part quality. So we can drive a lot of that through within the application, really. So just last off then, just a quick video just to kind of show it being in play, really. So we have at the top left and the bottom left the physical robotic cell moving around. And this is the process that was developed of the robot moving around these pogo sticks. And then just if you look across at the top right and the bottom right, is we have this virtual representation being driven by the live and digitally coupled state information coming through. So just at the four corners there, you can see that we have a digital twin, or that supervisory digital twin. Then across the middle is that discrete event simulation, looking at what's happening as this process is coming through. So we have driven the simulation through to also then monitor that into the application. The key challenge here is once this information is then available, is that other aspects of the shop floor can then start to utilize it. So here we have one single process on a shop floor, but how does that tie into storage, or how does that tie into forklift utilization as some part needs to be taken off its manufacturing line and put into something else? So whilst this program of work developed an understanding of how to do it across an architecture, is that actually now is we're looking for, well, how does that tie into the wider network? Once you have these pieces in place, what's the knock-on effect, and understanding that we can actually now have driving across the shop floor network across the whole enterprise. So here's just a quick summary then of how we've done it. So we have that live and connected information. We've got the digital coupling through the Factory Plus. We've got all of the state information of what we want to describe, just to understand what we have as JSON. We have the physical asset that we're working with, and we have that virtual representation of understanding the process that we're looking at. And then we have that functional output in this case of the immersive environment, but could quite have easily been a dashboard or however else you wanted to visualize that information for the use case. So just last off and sort of last slide is, a lot of the times digital twins is spoken around as this new technology or a new way of doing something. And yes, it is a new way of doing something, but at the end of the day, it's more of an approach rather than fundamental new technology, as the technology and the individual parts we've had for quite a while. So just a sort of concluding thoughts really of, if it is just an approach, then how should you approach it? So what our recommendations are is start with a use case. Start to understand what that fundamental problem is and opportunities that exist that need to be addressed. So looking at, what do I want to do? What do I need to solve? Is delays of this program of work, or is this manufacturing process being too slow? What do I want visibility of? What would make that job better? And then you have to go through kind of the adoption and buy-in, the design and architecture and long-term. And I leave these more here for sort of reading as kind of you digest the slides afterwards. But the key thing here is, if you end up with a digital twin and live and connected data, then great. If you end up with just a simulation that still delivers you business value and you can use that whenever you need, then also great. It's understand what technology is right for your business and right for the people that you're working with to deliver them the best value. Don't focus on having a digital twin, and I must have a digital twin because it's the biggest buzzwords I keep hearing about, and I must have one as a business. You probably will come across them and probably will start to have digital twin deployments, but it doesn't mean that it needs to be the buy-in for absolutely everything you do as a business. So thank you for listening. This presentation was very heavily based around the untangling requirements of digital twin report, as you can see here at the URL at the bottom right. If you've got any further questions, I'm more than happy to take any now, or feel free to digest and reach afterwards.
Thank you, Jonathan. Sorry for the slight disturbance that occurred during your talk. Very fascinating and very insightful talk overall, covering a big range of things. As you said, in the end, it will take a lot to digest for the people who are not very much into digital twin yet. So it's my request to the participants that you can either ask questions directly or type your questions in the chat box, and I'll take one by one. So I'll kick off by 2 questions, Jonathan. So as you know, there are myriad of manufacturing processes, both covering both additive and subtractive, or from bulk and surface manufacturing perspective. Have you at any point of time looked into benchmarking of those processes as to which particular processes are more amenable to DT and those which are not, for example, and what are the real challenges in those? And the second question is something which we face today, is being buzzed about: what is the trustworthiness of the DT system?
Yeah, 2 very excellent questions. The first is, I've not specifically looked at the different types of technologies and where they're being most appropriate. One thing that I am seeing common across a lot of these deployments is understanding where that value and use case first is. And a lot of that time comes down to understanding the very top level understanding. So it's not necessarily the which technology should I go to as which vertical slice should I invest the most in. A lot of the times now it's more about taking a horizontal slice, understanding the impact of, as a business, what is costing us the most money. If you're looking at trying to save energy as a business, well, where's your energy being spent currently? And without that visibility of which department or which group, then you can start to drill down into the little pieces of, well, is it this machine or is it sort of this whole shop floor section? And then you can invest more into understanding, well, what asset on that shop floor is causing the cost. So I see it being a different approach from what manufacturers are actually doing, rather than going, I need to focus on a certain technology. My current experience of 3D printing, though, is that there's still a lot of work being done in 3D printing. And because of the gigabytes, if not terabytes of data that are produced for a print, is that it's still very much a post-processing effect. So terms that you'll often come across more is around digital thread, digital shadow, and ideally linking those through to digital passport. So I appreciate they're probably sort of more words that you perhaps may not have come across. It may be a different talk altogether. But it's kind of, how do we gather information across the life cycle with digital thread? How do we collate historical data with its digital shadow to allow historical analysis to predict what to do in the future? And digital passport being the way of, what data do we need to capture as we go through a process to enable us to have that digital thread? So when you do a 3D print, is it the completion time, or is it more important of what was the ambient temperature of the room when that print was being done? So it's more of those data snapshots as it's going through. I hope that answers the first part of your question. That's at least my understanding of what I've seen in the space, and can only go off my own experience with that one. To answer your second question, yes, trust and security of data is a big one. And it is what people are trying to put patents in around this and have brokered interactions. The IOTIX example I provided in this one, they have another use case around work they've been doing with Rolls-Royce Power Systems. It's exactly that of train systems within the UK, is there may be 4 or 5 different manufacturers that all have a stake in having and sort of supporting the rail infrastructure. So train positions may be down to the operator that have GPS locations. How do they reliably secure that so other aspects of their business or other even vendors utilize that information securely, just to make sure that the value of what other people need is available? The challenge there, of course, is if you're the train operator and you put a GPS locator on your train and you tell everybody where it is, then you're providing that information, but you're not the person that's extracting the value. The train maintenance team is the people who want to know where the trains are going to be at the end of the day and where they are, and when they first go off track, and to say they now end up at a different location, they're the people who's going to extract the value. So it's not even, and I appreciate it's a bit of a side tangent, it's not even just about how do you trust the data, it's about the data that you're even trusting and providing, you might not even extract the value from yourself as well. So, but the bigger picture, of course, is that cybersecurity aspect of the trust in the data, what's available to who and why, is all a big IT question at the moment. Completely agree. And there are work being done in that space. It's just, it's a long time coming with a lot of that stuff of the academics almost catching up, dare I say, of manufacturers are wanting this, well, years ago. And there's still a big, as I think for the first time in quite a number of years, academic community is trying to catch up and understand where are the gaps to help us move forward in this space, because companies are already doing it and we want to know how we can help support them the best.
Great, thanks, Jonathan. Anybody from the participants would like to ask some questions to Jonathan? If not, I'll continue, Jonathan. So I have one more question. Is it too big of a leap to think directly about digital twin, or in a way, are we technically ready to go there yet, or is it fine just to think even of a digital representation or a digital shadow at this stage, so that you can make human intervention into the decision making by just seeing the process rather than having a fully automated, integrated decision making system that is the whole purpose of DT?
So a DT can have that aspect of just visualizing information. And that's really one of the key drives of understanding what we are looking at achieving. So these kind of that almost first pass is what we're getting to. And what we are seeing solutions come out for now is, if you can live and connect information to us, we'll give you the dashboards for free almost. Like if you just want to understand what your asset's doing, then you can have this representation. What we're then seeing is, by just enabling the back-end systems to understand, is whenever you get this data, log it historically. And then, like you say, you can build on the historical, you can build on the prediction tools, you can build on all of these other solutions that you want in the future, but you're not necessarily doing it now. So I think a lot of the time is that people are looking towards the integration of data and understanding it and doing the integration once for their machines. And then, like you say, they're building on it in the future for prediction tools, kind of simulations on top of that. How do they want to best utilize that information? And one thing that we are seeing a lot more is, once you've integrated something once, within a company, you may get 2 or 3 emails straight away going, oh, you've done that, or we could use that information now. And all of a sudden, it's a very much a growth of, I didn't know you could do that, or I didn't know I could rely on this information now because it's now available and brokered across the system. Is that actually from one thing you get 3, and from those 3 things it grows. And all of a sudden you think, well, actually, I've just done it for this system. Well, you can do it for this system now, and here's how we've done it. And you get the growth of the understanding from the business. And that's honestly the best way that we've seen it grow, because not only have you got the issues you've mentioned just then of sort of cybersecurity and everything else, it's cultural change as well. And somebody's so used to going down and checking machine every day because they could that was their job, they wanted to go and check on it, but now the live information is telling them it's okay. There's a big cultural change of how that changes within a business. Now, alongside that, you've also got the aspect of a lot of people nearing retirement age have also got a lot of that tacit knowledge inside their head. So it's kind of all working in pieces of they are experts in their field, and we want to try and capture that knowledge with a digital twin, in addition to capturing it historically, as well as the cultural change of bringing them along on that journey for why we want to do a lot of this and how we want to work with them to get a lot of this information outside of their heads as well.
Great. Thanks, Jonathan, again. Again, if anybody else want to ask questions, please do ask.
Hi there. I have a wee question, if it's okay.
Yeah, please go ahead.
Well, first off, thanks for the presentation, Jonathan. I really like the way you laid out the requirements of digital twin. It was very nice, very, very clear. You mentioned about this construction example where you have 20 odd apps on a tablet and, you know, everything's kind of siloed, and also about MQTT and OPC-UA. Now, obviously, a lot of this digitalization is coming in kind of piecemeal in industry. Do you have any thoughts on sort of best practices for future interoperability in designing these type of systems and implementing them?
Yeah, so it's part of the work that we're doing now. So Factory Plus was a program funded under Catapult investment last year, and it's now what we're continuing this year on exactly that, of how do you define those interoperability standards around how you describe this state information, how you monitor that live across the system? And you're right, especially in the construction sector, when you have multiple vendors and multiple manufacturers all wanting to support everybody, then it's difficult because no vendor wants to work together. They all want to keep it in-house, they all want to do it. And now with sort of as a service, sort of you're paying by the hour that you're utilizing that asset, is not only your business models changing, but the way that you interact with those business models are changing as well. So there are open standards being worked on. We're seeing a lot more recently within the open source communities. So Eclipse Sparkplug is just one for enabling sort of the communication brokerage, like say the MQTT is quite prevalent within that. And there are others of, well, here's a universal way of describing the device that we're utilizing live. But yeah, it's very much a, fully agree, it's a bit of a gray area at the moment. There are people working on it, and all that sort of what I am seeing, sort of one of the more active communities, especially within the built environment sector and construction, is the CDBB. So I'm working quite closely with the CDBB, so Centre for Digitally Built Britain, who are looking at a lot of these things of having sort of the water utility companies to working together in the UK, or other sectors in the UK coming together to say, look, we're all in this together. How should we go about this? As well as having then the overarching strategy of, well, water sector is doing this, energy sector is doing this, kind of, are there even commonalities between all of these actually working together as well? Because the whole point of that UK national infrastructure challenge is not only do you have the silos and the information sharing between themselves, it's also how do we bridge it all together as well to have the best infrastructure possible.
Great. We have Boyan ready to ask another question, Jonathan.
Hi, Jonathan. Can you hear me?
Yeah.
Okay. Thanks. It's a great presentation. I think they have a lot of great work you have presented here. There is one thing I feel quite interesting is on your page 33, there is a unified namespace. So on this graph, you have showed they have POC, MES, SCADA, ERP, which is the current existing manufacturing information structure. And you have put digital twin at the middle of the space. So actually, it is quite interesting. So where should the digital, if we develop a new module called digital twin, where should they be placed in this architecture, in the existing architecture? Are they a new part, or are they going to replace some of this part? The other things is, I think this start for asking this question is quite interesting. Other things, in your experience or knowledge, is there any digital twin can connect of the information system you list here? So yeah, that's my two questions. One is the position of a digital twin in the existing manufacturing infrastructure. The second is any state of art or practice that have already successful connect of the information system.
Yeah, I'll answer what I can on the second, and I think I understand where you're coming from. The first is a lot of the work currently being done in manufacturing, and again, I am manufacturing research, so I'll answer what I can more broadly. A lot of architectures don't look like this currently. A lot of the architectures is PLC to ERP or MES to ERP directly. So whenever you need to access the same PLC information, you're integrating again. And then when an MES needs to integrate with a PLC, your MES then talks direct to the PLC. So you end up with communicating with the same device 10, 15 times. And that's the whole reason behind Factory Plus. And it's one of the main drives behind a lot of these unified namespaces is that you integrate once, you broadcast to the network, hey, I'm here, I'm alive, this is how you can understand me, this is how all the information that's available, utilizing what sort of, Shay was just on about with the interoperability of, this is my universal description of how I want to be spoken to and greeted, and kind of, also when you need me, read only or those kind of things is, yes, you may have this piece of current information, but also be aware, I'm measuring that in amperes and you can expect it roughly about 10 hertz. Okay, great, I can consume that information. What that means is then, digital twins, as long as you've got access to this unified namespace, can be integrated anywhere. More commonly, we are seeing it deployed centrally on, if it's a prediction model, it may be a container that's spun up and orchestrated to enable that to be run once a day. Or it may be sort of understanding of just then having dashboarding coming off this unified namespace to say, I want to integrate with the unified namespace because I want to understand utilization across the 20 machines on my shop floor. So you have the 20 machines connected to the unified namespace, then you have one digital twin coming off it as a supervised digital twin, just integrating with utilization of all the different machines. So it's very much about understanding the geolocation, I guess, a lot of the time of where and how you want things to be deployed. I must admit, from the normal aspects of deployments, this is simplified by quite a lot. Normally, you've got at least sort of 10 different firewalls on site to get through and understanding where these are actually being utilized. But typically, sort of abstracting it away, we are looking to all have this unified namespace, and it's what we're working with sort of quite a few AMs around of sort of reinvigorating it a little bit to say, look, this is the types of deployment you need, and this is why. If you're actually interested in a lot of this, the website I mentioned here goes into a lot of detail around why we down-selected Sparkplug and over OPC UA and why we went more towards an MQTT architecture. There's lots of information there, and by all means reach out afterwards if you've got any further questions, or I can put you in touch with the development team. To answer your second question, if you could just repeat it, please, and I'll just try and make sure I'm following you with that.
Thanks to answer the first question. So the first question is about where the new technology should be the existing manufacturing information system structure architecture, how to mock up the existing one, or we create a totally new one. The second is about in your knowledge, do you have you seen any kind of this kind of digital twin have already connect the whole shop floor or the information system for the whole factory, which you listed here?
So yes and no. So yes, I've heard of it. No, I can't talk about it. Unfortunately, is the way is people are doing it now, and people are connecting whole systems across the shop floor. What they are doing in a lot of cases is connecting little pieces. So they're saying energy monitoring, our company spends X £1,000 on just energy alone, but they have no visibility on what is costing them most money. So they're putting C clamps on things and just having that visibility. So it's very much that horizontal spread I was describing earlier around, we want some information. We don't know where we need to deep dive yet, but at least let's give us that traceability on understanding where things are going with sort of that connectivity and whatever else. Some aspects, as you saw with the Frazer-Nash example as well, is very much that deep dive. So if you have a specific use case and you're like, look, this is costing us so much money, we need to try and resolve it and understand what we can do better, then yes, you can deep dive. And there are examples around that. But typically for shop floor and connectivity, it is very much that sort of broad spectrum around understanding a whole process or understanding full connectivity across the shop floor.
Thanks for your answer.
Great. I think we are close to time, Jonathan. So if there are any other questions, then I would request the participants to directly email it to Pamela, and then we will pass it on to Jonathan via email, and Pamela will get back to you with that. So on a closing note, Jonathan, once again, we'd like to thank you very much for giving your precious time and preparing this nice presentation and to interact with the DSM family and the community. And we look forward to see the new developments and engage with you again. Thank you very much for that.
Thank you everyone for listening.
Thank you. See you everyone. Bye.